Alrighty, welcome everyone to the August community meeting of the OAuth Dependency-Track project. First, some organizational stuff. As always, these community meetings are being recorded and they will be uploaded to YouTube, mostly within a delay of like 1 or 2 days. The slides that you see currently and the slides of guest presentations ideally are being published to the Dependency-Track community repository on GitHub. If you have questions during the presentation, please do ask them using the Zoom chat. If it doesn't work for some reason, let me know and I can see why it doesn't work, but it should work. And we will have a dedicated Q&A section towards the end of the presentation where everyone can ask open questions essentially. In general, we would love to host you here to have a guest presentation from you. Either if you have built a cool setup with DT, if you have complaints, if you want to rage about something, if you want to propose changes, anything you want really. We would love to host you here. We would love for you to give you a platform to present to the community. I think those are very valuable presentations, more valuable than us from the maintainers talking to you. As for the agenda for today, I will just quickly walk through recent releases, upcoming releases. Then we have a guest presentation from Florian Schmidt about component health integration into Dependency-Track, which I'm very much looking forward to. And as I mentioned, the Q&A section at the end. First, just quickly, recent releases. Version 4.13.3 was released this Monday, August 4th. It includes 10 bug fixes since the last bug fix release, as well as some base image updates and dependency updates. Especially noteworthy here is a significant speed up in the internal vulnerability analysis if you have components that have CPEs, and also improve performance of bomb exports, in particular if your components have properties. There was a community member who was complaining about bomb exports taking upwards of 30 seconds, which obviously is way too long. And with this fix applied, it only takes just above 1 second now for him. I wanted to spend a few more minutes on explaining why exactly the vulnerability analysis has become faster, because I thought it was quite interesting. Basically, if a component has a CPE, you can see here, this is a basic CPE structure. You have CPE colon, CPE version, and then what is called a part in the CPE world. You can either have A for application, O for operating system, and H for hardware. And then there is the vendor part, which is here foo, and the product part, in this case, bar, and then version and some other properties. And you can have wildcards, which are then asterisks, right? So what we do when we get such a CPE value is we look in the database, and the query roughly looks like this. So the vulnerable software table that you can see here is where we store information about which CPE is vulnerable to which vulnerability, essentially. And because like when the vendor has the value, the incoming vendor has the value foo, we have to look for all values that have either the value foo exactly or any, right, asterisks to match records. And we have to repeat this for every single property of the CPE, in this case only for part, vendor, and product. And the surprising part here is that if you look at the query plan for this, the database decides for whatever reason to use a parallel sequential scan. So it doesn't use any indices here. And you can also see rows removed by filter. It loaded 80,000 rows and discarded them because they were not relevant. And in this case, this is on my local machine. There's no network latency, very fast disks, and it still took over 30 milliseconds, sorry, to return no results at all, right? And if you have thousands of components, or especially like 1,000 components, this is already 30 seconds of time you spend just in the database querying, and this is not accounting for network latency or anything like that. So this is where we started. The thing is, all of the involved indices or all of the involved columns are indexed. So the question is, why doesn't the database use those indices? And it turns out that if you use OR conditions across multiple columns, the query planners of the database get confused or they don't want to use indices. So what works is, surprisingly, you just explode the query. Basically, you generate all the permutations that were previously that were previously created with OR conditions. You explode them. In this case, we end up with 8 subqueries, which we join with union. And this is pretty much equivalent to the OR query before. But what happens is, even if the query plan looks more expensive, every single query can now use an index scan, and the entire thing takes under 1 millisecond. So if you now scan 1,000 components with this approach, you still end up being under a second, right? 100 milliseconds roughly. Yeah, this was sometimes more is less, I guess. This was fascinating to see, actually. Yeah, we also released Hades version 0.6.0. We released it end of July. It is basically a save point release, and we will merge more intrusive changes now after this release into the code base. We started to modularize the code base as well, which means that we can now have parallel builds and build caching of modules, which means faster local builds and faster test runs in CI. We also introduced a new major version of the REST API, which is, I guess, good to know. We now use an OpenAPI spec first approach. So we write the OpenAPI spec, generate code from that, and implement interfaces, for lack of better words. This also allows us to introduce tooling to our CI pipeline, which keeps us consistent or keeps us honest. So we have tooling in place that ensures that our field names are consistent, that we do not introduce breaking changes, etc., etc. So we really want to make this spec first, and we really want the REST API to be a contract to you as the users, right? And prevent us from introducing breaking changes or inconsistent changes. For the foreseeable future, the version 1 of the REST API that you currently know will remain there, but we might end up deprecating certain endpoints that we replaced with version 2. This will also be this is the last release that includes the Kafka requirement. I mentioned this before. Kafka will be removed in future versions. For upcoming releases, version 4.13.4 and version 4.14.0, the major or the biggest planned changes, I guess, would be first support MVD feed files in version 2.0. At the moment, per default, Dependency-Track uses the feed files in version 1, which are reliable, I would say. But they contain outdated information, or they don't contain all the information that you can see on the NVD website. There's also the ability to use the NVD REST API for mirroring, but the REST API has been very unstable in the recent past. So what the NVD people have done is they took the data from the REST API, put it into feed files again, made them available for download. So we will move to that again. We could deprecate the NVD REST API mirroring functionality in DT. We could also remove it completely. I would put this into, I guess, depends on when we want to release this. If we release this in the next bug fix release, which might happen, we will not remove the REST API mirroring. If we release this with the next minor version, we might remove the REST API mirroring, just because it serves no purpose anymore then. There's also currently a bug where you can run into infinite recursion or endless recursion when you open the dependency graph in the UI. We are aware of this bug, and we will fix it for the next bug fix release. And more generally, get a hold of all the open pull requests at the moment. I know they have been piling up, and we will try to get more of those changes in the next minor release. For the next Hades release, we will, as I mentioned, remove the Kafka requirement, introduce a durable execution engine. If you're interested in that, look at the previous community meetings. We demoed a little bit of that, but also discussed what exactly this entails. We will be introducing a plugin mechanism and publish a plugin API. This just happened to be something that we needed internally. Like if a certain functionality can have multiple implementations, we wanted like consistent configurability of those implementations. And in hindsight, it made sense to externalize this plugin API. So ideally, you as community members or you as active community participants should be able to implement your own plugins and customize Dependency-Track in the future if you want. We will as part of the Kafka removal, we will also discontinue various services that we have spawned since Hive started. And we will also update the front end to leverage the new REST API version. Specifically for the REST API, this is important to mention, is we will change how pagination works. At the moment, the version 1 of the REST API is offset-based, which has very bad performance as soon as you will move on to later pages in a large data set. So what we will do is we will move to something that is called the seek method, or key set pagination, or token pagination, depending on where you're coming from. And the navigation then works with next and previous links rather than offset and limit. As I mentioned, it's better suited for large data sets, which we are striving to maintain, I guess. I don't want to bother you with details. There's a very, very good site about this on the internet. It's called Use the Index Loop. They have amazing documentation about why this is the better approach and why you should use it. So if you're interested, please just refer to this page. With that change, there will be a question as to how the UI will work. At the moment, you can navigate to specific pages, right? When a view has more than 10 items, for example, you can jump to page 2, 3, 4, 5, 6, whatever, and then you can sort the entries. So that is how you can navigate to certain entries in the table. When we change this to only be able to navigate to the next or previous page, this type of navigation will not work anymore. You will not be able to jump to a specific page. So what we want to offer instead is give you more filtering options. You can see a very, very rough, very, very basic implementation of this here. Here you can just filter by name contains, right? But ideally, you should be able to filter by name is equal to, name starts with. If there are date fields, you should be able to sort by from and to date ranges, right? You shouldn't have to jump to certain pages to get to the data you want. That's basically how we plan to implement this change in the front end. Again, what you see here currently, very, very rough, but that is the direction that we are going to get into. More filter options, no more jumping to page 10 of 10,000. Let me see. I think there were a few questions in the chat. Can I get it open? Someone created a feature request. Okay, I will look at that. Same it was GitHub does with their APIs after key. Yeah, pretty much that. Yep. Will the NVD version 2 feed files be compatible with those generated by vulns? In other words, can I use my already mirrored files in DT? I'm not sure what it should be. I'm not sure if the Open Vulnerability Project is currently using the REST API or if they are still using the legacy feed files. But if they are currently using the REST API, then the data should be equivalent and you should be able to use it that way. But I'm happy to look into that. If you maybe want to raise an issue about that in GitHub, that would be helpful. Yeah, sorry, just trying to answer the questions that have piled up in the chat. Then I think we're up for the guest presentation. Florian.
All right. Thank you very much. Let me take a couple of seconds to get set up here. Okay, this seems to have worked. I hope you can see my screen. Perfect. All right, so thank you for the introduction. My name is Florian Schmidt, and I have the honor of speaking to you today about my thoughts on the integration of OpenSSF Scorecard and other component health metadata into Dependency-Track. Now, for starters, a couple of words about me, myself. I'm a master's student in computer science at the Technical University of Munich, and I'm currently working on a master's thesis in the area of software supply chain security, affiliated with the Fraunhofer ISEC Institute and Rode und Schwarz in Munich. And the overarching goals of our research are essentially, when it comes down to Dependency-Track, twofold. So first of all, we want to figure out a way to provide developers with a better basis for decision making in dependency selection and in dependency evaluation. So just provide data and contextualize this data to allow them to better evaluate their own dependencies, to understand what is going on in their SBOMs. And number two, from an organizational perspective, we want to equip organizations with a better quality gate or baseline for the security posture of their own projects. So again, understanding what is going on in their projects, in their SBOMs, especially with the help of automation. Now, referring back to the call for guest presentations, we're essentially here for number 1 and number 3. So kind of do want to brag about the cool DT setup we've built, and also very much want to get input on dependency track related design. So if you have any feedback for the stuff we're building here, hit me up either right now in the meeting or even later on Slack or on LinkedIn. So very much open to hearing your thoughts on this. So again, thank you very much for hosting us, and let's dive right in. So I guess for your crowd, I don't have to explain the background of this XKCD here. So we all know the situation too well. For many open source projects, this comic is not a joke, it's more documentation. And in these kind of tight-knit ecosystems, especially when talking about Maven, NPM, PyPy, situations like these can arise fairly frequently, with a lot resting on single packages and their unpaid and often underappreciated maintainers. And this has, of course, led to issues in the past, with single maintainers of packages facing difficulties of various kinds, with all of the implications that stem from that. So thinking about incidents like core.js and NPM left pad or event stream, stuff like that. So these kinds of supply chain attacks that, of course, affect a lot of all modern digital infrastructure. So the conclusion in this case, of course, it's crucial to understand your dependencies and to know what's going on in your projects and in your SBOMs, and dependency track helps with that, of course, and we want to improve that even further. Breaking down these high-level goals, what we want to do with this integration basically is, first of all, we want to enrich the component metadata that is available in the system with more insights on development activity and maintenance of projects by, first of all, supporting OpenSSF Scorecard. So that is a cornerstone issue that has been open in the GitHub 3048 if you want to read further discussions about that. So we want to solve that. And in doing so, also retrieve some other key project health metrics that can serve as proxies for development activity and the project health in these source code projects that belong to the components that you manage in dependency track. So looking at things like contributor count and the commit activity in these repositories, the bus factor, so to speak, so the number of contributors that are crucial to that project, or things like issue count and age. So how old is an issue on average? How long does it lie around in a repository before being closed? All of these things that can serve to contextualize the project's health and development activity. And while having data is nice, automated usage of this data is even nicer. So what we also want to do is we introduce a health variable in the CEL policy environment that V5 will support, which then enables you to write policies for kind of rich combinations of health and vulnerability data. Why is this so interesting? Basically, what it allows you to do is it supports kind of context aware, let me call it that, dependency assessments. So what do I mean by that? You have a couple of data points already available. So things like you have vulnerabilities in a project, or now with the new health data, project maintenance. And in this case, both of these signals taken by themselves might not indicate that big of an issue with a project. So if you have a project that has a critical vulnerability, but is otherwise well maintained, has responsive maintainers that listen to security advisories and disclosures and all of that, and jump into action and either determine that this vulnerability does not apply to them, so the project is not affected, or in due time publish a fix, then that by itself might not be that big of an issue. Likewise, project maintenance activity by itself is also not that big of an issue. So the lack thereof does not necessarily indicate a problem with that project, because some projects are just feature complete. So there's no longer any development going on because there's nothing left to do, because the project fulfills the functions that it was intended to fulfill. However, when each of these signals are contextualized by the other, so you have a project that is not actively maintained, but you have a reason for something to be going on in that project, which would be a critical vulnerability that needs to be addressed, then this is an issue. And this is why kind of the combination of this hard vulnerability information with the activity information is so interesting. And this is precisely what we're setting out to solve with this new data. Now, looking at what we have now in this proof of concept, like first iteration of the implementation, is first bullet point stuff pulled from the GitHub API. So stars, forks, contributors, commit frequency, open issues, pull requests, when the last commit was, bus factor, etc. The note that the bus factor does not get computed by GitHub. You have to do that yourself, but you can pull the relevant source data. And bullet points 2 and 3 refer to the OpenSSF scorecard. So you have the overall scorecard score of these projects, and then these scores for the individual scorecard checks. You might ask yourself, why is that typeset in monospace font? Because that is precisely what is available in the health variable in the policy environment. And I promised some policies, and I also have some with me. Let's go through these 3 examples quickly to kind of get an idea of what you can do with that data. So first of all, called it unmaintained, stale, and vulnerable, represents precisely this idea. So you have we discussed earlier, so you have a project that scorecard deems to be not very well maintained or is fairly old, so older than half a year, and has a vulnerability that has a high or critical severity, which would indicate something is going on in that project. There's not enough maintenance activity to properly address this, or there might not be enough maintenance activity to properly address this, and you should look at that dependency. Similarly, with possibly different violation severities would be the other policies. So low activity and old issues would represent a project that has an average issue age of more than a year and less than 1 commit every 2 weeks on average. So issues possibly piling up or getting rather old in that repository. And the last policy, abundant but widely used, represents a project that has had no commits for a year and has more than 100 dependents. So not dependencies, but rather dependents. So the other side of the dependency graph. That's also something you can pull from external APIs. So these policies here, somewhat deliberately permissive in order to generate more results. And looking at results, it's demo time. Let's hope the demo gods are with us today. I have prepared, and I hope you can see. Let me check the Zoom preview. Yeah, I hope it's large enough to read. I have prepared a dependency track instance that is running these changes. And in the projects, I have imported a SBOM of a current version of the OWASP webcode. So this backend Java application that is used for security testing. And let's have a little fun with it, shall we? So let's go into this project and look at the component table. First of all, you might notice there's a new column, the OpenSSF scorecard score of the components in that SBOM, which now allows you to sort by them and check out your dependencies. So which of them have fairly low scorecard scores. For example, this jQuery WebJar seems to only get a 2.6. And also, of course, check out which of these have the best scorecard scores. So these Log4j APIs or Guava and JSON seem to get some reliably very good scorecard indications. Now, maybe we were a bit freaked by this and want to check out why the scorecard score is only 2.6 for that dependency. So we can open up the component overview and have a new health tab that gives you all of these component health metrics here in the front end, somewhat still of a rough and beta UI. So that can, of course, still be finished up for production use, but you can see the essence of it here. So you get all of this component health metadata, this up here pulled from GitHub. So a couple of stars and forks, 3 contributors, of which 1 seems to be the main contributor. So the project has a bus factor of 1 and apparently has had no commits since August of 2023 and also fairly old issues. If we look down, we can also see some repository features, seems to have a README, does not have a code of conduct, and also does not publish a security policy. And in the scorecard checks, you can see the OpenSSF scorecard scores for the individual checks. So as published by Scorecard, so the project seems to get a 0 in the maintenance indication because no commits and no issue activity in the last 90 days. 10 out of 10 binary artifacts, no binaries in the repository, etc., etc. So you can look at all of the specific indications in here and get an idea of the posture of that individual component. Now, I've hinted to it earlier, having data is nice, automating data is even nicer. Let's hop on over to policy management. And here you can see, among others, the policies that I showed you on the slides a couple of minutes ago. For example, this one, unmaintained, stale, and vulnerable, representing exactly this idea. There's no development going on, but there is a vulnerability that would mandate that. And also, of course, the others, so low activity and old issues, or something like, if it interests you, single maintainer risk here, that would inform on a bus factor of 1. So a single maintainer doing the majority of contributions to a project. So all of what I've showed you, valid CEL, and can be executed on these projects. So again, somewhat deliberately permissive. We get 195 results from these policies for the WebGoat project. And if we now look through, unmaintained, stale, and vulnerable triggers a single component, this X stream 1. And if you look at it, why that has happened, well, basically, it seems to have a maintained score of 3 out of 10 with 2 commits in the last 90 days and a couple of vulnerabilities, among them also a critical one. So this might be an indication to look at this dependency. Possibly there's another version or something else you can do about that. Filtering for the others, low activity and old issues triggers a couple of them, so 19 results here. Among them also the jQuery dependency with the low scorecard score that we looked at earlier. And there is basically no limit to what you can do here because you can freely use the data and tune these thresholds any way you like. jQuery, for example, also triggers the abandon policy because it has had no commit for over a year. And lastly, you can also look at the one after P9 here, single maintainer risk. So there seem to be 60 results in the OWASP WebGoat SBOM that are mainly maintained by a single person. Now, let's jump back to the presentation and skip over all of the screenshots. These are for, first of all, your future reference and also my help if the demo would have not worked, but it did. So let's dive into some technical details. Anything discussed here is also listed in the ADR number 7 in my hiatus repo fork. So if you want further information, I would refer to that in more detail. What do we propose basically? It would be, first of all, an expansion of the repository meta-analyzer service with integration for this health metadata. This is kind of threefold. So first of all, we are fetching more data on the component abstraction level from the DepStef API, so Google OSI, which would be mainly the scorecard and the number of known dependents, because that API also delivers that. Then, second of all, we map to the source code repository, because that is, if you think about it, not really trivial. So you have components on the one side and you have source code projects on the other side. And in many of these package repositories, the information about that is published as well. Sometimes it's contained in the SBOM, if I'm not mistaken. And DepStef also aggregates that nicely in a central place. So you can use that service to kind of map from the component abstraction level to the source code abstraction level. And then you can use that after you've mapped to retrieve any number of statistics or information that you want about that source code repository. We do that here for contributor statistics and all of the repository metrics that I've showed you earlier. This whole thing then gets persisted in the health meta component table in the database, which is mapped by Perl coordinates, which means that you can reuse that information for other projects. So of course, you don't have to keep that twice in the database, and you also don't have to fetch that twice if you already have projects that use this data. It of course needs to be updated in a reasonable time frame, but this can be taken care of. We also provide API endpoints to access this data. Of course, that's also used by the front end to display it as per the component view. Now, we also have to retrieve and map this data in the CEL engine. So to populate the health variable in that policy environment with the kind of added step of complexity that might also be taken over or could be taken over to the other fields as well, if that is desired, to skip the evaluation of a specific policy if the fields that are used are not available. So we could have cases for components, for example, where the OpenSSF scorecard is just not present because scorecard does not execute on this project in the public data set. And there, of course, you would not want to fail that policy just because the data is not available for a specific component. Now, page 2. Potential limitations. Of course, there are also some. Currently, this implementation is limited to components that are listed with DepStef as a central mirror for all of this data and that are on GitHub. Furthermore, you would need authenticated API access for accessing the GitHub API. This needs to be registered in the repository settings in Dependency-Track, but that's not a big requirement, just something that needs to be done. On the other hand, you have some partially quite high processing and retrieval time, especially with certain GitHub API endpoints, particularly looking at the ones that are interesting for contributor statistics and computing the bus factor and the amount of relevant contributors in there. Because there it is often structured in a way where you start the computation via the first API call, you get an accepted response code back, and you have to request again for your results after a period of time has passed. And this varies. So it takes sometimes 20 seconds, sometimes a minute to compute this data on the GitHub side. And this, of course, kind of slows down the retrieval time on the dependency track side of things. In some cases, you also have the typical problems that always occur if you're working with external data. So quality might not be that great. So sometimes you can't map to source code repositories because certain projects use, for example, forwardings via different domains or that have not very clean project links in their data. But as you've seen, in most cases, works quite well. So you lose, of course, some components, but still the majority of ones work quite well. And again, don't have all metrics available for all components. Well, kind of an inherent limitation with retrieving external data. Lastly, we're still depending on Kafka, same as the rest of the repository meta-analyzer service. This is currently, however, or should be, in my opinion, fairly easy to refactor because there are no new communication channels introduced in this case. So what we use is the existing channels with an adapted data model to pass through the health data over to the API server, and a new command that triggers the meta-analyzer service to fetch all of this data. All right, so if you want to get a look at the implementation yourself or maybe play around with it, here are the links to the relevant source code repositories, so the fork of the API server, of the Hiatus services, and the front end on my own GitHub. Again, referring to the ADR in the Hiatus repository. So feel free to play around with that. And here we are. So quick summary again of what we've done. So new metadata, scorecard, health and activity, retrieved from external sources, supplied to policies, and rich combinations of health and vulnerability data. Thank you very much for your attention. I would be open to any questions.
Thank you so much. Great presentation. Great stuff. Loved how you integrated the cell policies. Sorry. Really, really cool.
Thank you.
I would propose everyone who wants to ask a question, I think you can unmute yourself. If you cannot do that, I will happily unmute you if you ping in the chat. Otherwise, there have been a few questions already, Florian. I will just start from the very first. Valerio says or asks, Florian, perhaps you might also consider building a list of alternatives for open source problematic projects so the developer has some actionable insights.
So if I understand that correctly, you mean alternatives to projects that are flagged in these policies?
That's how I understand it as well. So say Xstream is being flagged. Can you propose an alternative that people can migrate to?
Yeah, that
exactly
would be quite an interesting side quest that also digs into this kind of whole issue. You have then policy warnings occurring in your system, and how do you deal with that? So you need to kind of give the developer and the users some guidance. Otherwise, there could be easily like the situation where you run into this level of alert fatigue, where you just get used to hundreds of warnings and click them away because you don't know what to do about that. So very good point. Yeah.
I guess at the very minimum, one could have a description or a summary for every single policy that you write, be it very generic, but so that the person that is reading the violation knows, this is happening, so I have to look for alternatives. Of course, then the lookout for alternatives would be delegated to the developer, but at least they know what to do roughly.
Yeah, I imagine your IDE with some plugin that is creating Dependency-Track is flagging all the problems and then one-click replacement for alternatives.
Yeah, that would be nice. Agreed.
Definitely.
Okay, moving on to the next one. Roland is asking, what is the relevancy of the number of forks? Is having more forks a sign of better health or not?
I think, of course, matter of discussion by itself, again, might not be a very useful indication. However, I would still argue for it's a sign of popularity, especially if taken together with stars, watchers, what you can get from GitHub. So if you see that your dependency has a lot of forks, a lot of stars, it seems to be fairly popular in the open source community, which I would treat as a good sign. So would be indicative of better health. Yeah.
And I guess the beauty of the solution would be it's entirely up to you what you want to do with this information, right?
Yeah, precisely.
Moving on to the next one, Julian asks, really nice, could be linked with end of life information /support or something like XEOL, in parentheses hero dev, to be able to request, yes, there is no commit since 2 months, but it is still officially supported. Ergo, no violation. So I guess the question is about end of life information.
Yeah, this is another thing. Yeah, definitely. I know that site. I have not been able to do that in the scope of the thesis, but would be definitely interesting to kind of get this official information. So an official sign off, this project is still supported, which could also definitely contextualize that. So regarding all of these new data sources, so very much open to that. The architecture, I'm also in the process of kind of rewriting some of the fetching logic to be able to support precisely this. So what we want to basically achieve is we have three core problems here. First of all, fetch metadata about the package, then map to source code, and then fetch metadata about the source code. And basically all of these three could be solved with different and also kind of intertwined strategies that work together. So you could use different services. For example, also end of life to fetch metadata about the package or component level as well. So this is definitely something that from a technical perspective is definitely possible to integrate into that architecture.
Awesome. That received a heart. I guess that's a good answer.
Perfect.
Roland asks, I agree with Julian, no commit in some time, but has critical issues. Ergo, no issues are relatively new. For example, 1 week, not a big issue. He added, not a big issue yet. And then he added, I guess this can be done with cell.
Yes. So what I would read into that is, or how I would interpret that is, you would probably need a bit more of an expressive way of looking at or characterizing the issues in a repository. So just the average age over all of them might not be very representative, because you could have some long living parent issues where stuff is planned that kind of inherently have an age of 2 years or something and would push the average in that direction. So probably a bit more of an expressive way of looking at that would be useful, yeah.
Alrighty, Roland, I hope that, yep, that's a heart. I guess that's a yes. Valerio asks or says, consider GraphQL together the repository metrics. It's much faster and cheaper token-wise.
Okay, I will look into that. Thank you very much. Yeah, using the traditional API so far. So you get like, I think 5,000 requests per hour. But when you process large SBOMs, especially I looked at Juice Shop or Wasp Juice Shop as well, with NPM typically like 2,000 something components, you run into that rate limit. So I will look at that. Yeah, thank you very much.
The big thing is that you can batch multiple repositories and you gather metrics of, let's say, with one query, 100 repositories.
Okay. Yeah.
That's
Yeah,
going to
that makes
be
sense.
very effective if you have to monitor huge code base of dependencies, right?
Yeah. Yeah. So I think in this case, it could also make sense to re-architect this fetching pipeline to have some way of dealing with these kinds of long-running jobs, because that might not be exclusive to just the GitHub API, depending on what comes in the future. So there, it might be interesting to have a way to kind of batch individual requests for health metadata and also kind of do that asynchronously in some way, but might need some refactoring compared to how it is right now. But yeah.
I think what we're going to introduce next, the durable execution engine, that might help. It will also take care of retries. So if you run into rate limiting issues, you can just fail the job and the engine will then take care of retrying the task at a later point in time.
Okay.
But I can attest to GitHub rate limits being a pain. We recently had to modify the GitHub mirroring logic, and GitHub essentially has primary and secondary rate limits. The primary ones are the ones that count against your like official rate limiting, the 5,000 requests that you mentioned, but they can still decide to punish you with the secondary rate limit just at random times. If you request too much data at once or whatever else, they might give you a timeout for a minute or something. So yeah, that's fun to deal with.
It seems to also be present, especially the secondary ones across tokens, or also affecting the individual accounts. So if you do other requests or try and, for example, authenticate to GitHub via your IDE while such a job is long running with a token in your account. So I got failures in there as well. Yeah, exactly. Something to keep in mind.
If you ever need a very quick hack, you can run a CSD and fire all the requests from that CSD because it is an internal IP and it won't be throttled.
Okay. Interesting.
I think there are no more questions. So you mentioned the repository meta-analyzer still relying on Kafka. I agree with you that that is not a big problem. I think the chunk of this all, or the meat of it all, is how the data is represented in the database, right? And how it is retrieved, how it is made available to the front end and the cell engine. So I think that chunk of work is really valuable in itself. And the fetching, we can figure out how we migrate that over to the new model later. You also mentioned this is currently limited to GitHub and to deps.dev. So I think it would be an interesting exercise for potentially the community to solve, or for us maintainers, to make this work with internal repositories, right? If you have some organizations have air gap requirements, they may not allow you to connect to GitHub. So it might be interesting to make this work with GitLab instances or Bitbucket. I presume not all of these Git instances or not all of these services calculate metrics like GitHub does. So possibly we would have to do that ourselves. But yeah, would be a good exercise, I think.
Definitely, yeah. From a technical perspective, I think also the authentication issue would already be dealt with when you look at the way Dependency-Track manages repositories. So you could just create an area for GitLab in there and store your authentication tokens and manage internal instances there as well. And then it's just a matter of writing the retrieval API clients and adapters to fetch this data. And of course, there could be the case where you get different or not the same quality or a subset of metadata only from different repositories, but supporting Bitbucket, GitLab would be quite interesting, especially for like the centrally managed instances of Bitbucket, because many projects reside there as well, from the Apache neighborhood of Java stuff, for example.
Yep. That makes a ton of sense. Anyone else have any more questions? That does not seem to be the case. Then Florian, thanks so much for your work. Thanks so much for presenting. And also like personal thanks that you wrote an ADR. Much appreciated. Love to see it. Yeah, let's keep in touch. Let's get this
Thank you very much.
To production. Alrighty. Thanks everyone. See you next time.
Thank you. Bye-bye.